Hey guys, my name is Christopher Guzman, Senior Technical Artist here at Wise Engineering. In this tutorial, I'm going to give you some tips and tricks on how to light your scenes for VR. We are going to start by describing all the type of lights available in Unreal, as well as all their properties and how you can modify them to suit your needs in VR. Let's get started. Unreal offers 5 types of lights: directional light, point light, spotlight, rect light or rectangular light, and skylight. Directional light simulates the light being emitted from a source that is indefinitely away, making it ideal to simulating sun. Like we have here. I make this 100, and then I'll move it. It's like the sunlight is coming through that hole on the top. Point light works just like a light bulb in real world, emitting light from all directions, like you see here. Spotlight emits light from a single point into a cone shape, as you can see here. Rect light emits light into the scene from a rectangular plane with a defined width and height. Like so. And skylight captures the distance part of the level and applies it into the scene as a light. This means that the skylight appearance and its light reflections will match, even if your sky is coming from the atmosphere or layered clouds on top of the skybox. You can also manually specify a cube map, which you can see here. For each light, we have mobility settings, and this is very important when it comes to VR. We have static, stationary, and movable. Movable lights or dynamic lights are more expensive, and try to avoid them at all costs developing VR. They generate real-time shadows and can be moved at runtime to other positions. The only problem is that they'll be very expensive. Now, stationary lights are intended to stay in one position, but are able to change in other ways, such as brightness and color. This is the primary way in which they differ from static lights, which cannot change in any way during gameplay. However, it should be noted that runtime changes to brightness only affect the direct lighting. In direct lighting, since it's pre-calculated by light mass, will not change. And for VR, we always use static lights and light maps. This is the cheapest lighting option to render, since all your lighting is baked into a light map. These cannot be changed at runtime, so what you see is what you get. If you need to use dynamic lights by any chance, make sure to limit the amount you use as few as possible, and make sure that they never touch one another, because you're going to start getting errors. And these errors will just turn off shadowing information from one of the light sources. If you have an outdoor scene, you can use a directional light, as you can see here, and set it to stationary or movable. But in this case, we want to use stationary light. And we're going to turn Cascade Shadows. Cascade Shadows are like LODs for shadows. Your performance will improve since the farther you are from the object, the less detailed the shadow information will be, compared to ray trace shadows that are always on no matter what's the distance. Let's make this directional light stationary and scroll down to Cascade Shadows. Add a distance since by default is always set to 0. Let's add a distance of 200,000. For you to see the effect in real time, you need to make the light movable. After we are done, we can change it back to stationary. Now that we have changed it to movable, you can see the effect on the wall. So if we scroll down, we're going to change these parameters so that we can adjust the cascade shadows. Non-dynamic shadow cascades control how many levels of shadows are shown. The more levels, the higher the performance cost. Distribution exponent controls the transitions between shadows. Transition fraction controls the proportion of the fade between shadows, and distant fade out controls how soft the fade out is between shadows. Let's drag an object, in this case a sphere, and place it in front of the light. Let's say this is the dynamic object. In the shadowing of this object, you will see the shadow reducing quality the farther the camera is from that object. And that's what makes performance more manageable in VR while using a dynamic object with a stationary light. Now let's explain some of the tricks that I use to lit up this scene, because as you see it in the viewport is not what you get on the headset itself. In VR, what you have in your viewport sometimes changes depending on the headset that you're wearing. If it's an Oculus Rift, what you see in the scene is what you're going to get in the headset because it's being powered by your computer. But for the Quest, which is handheld, whatever you see in your scene is deceiving because it's not the same as the Quest. So once you create a look that you want, you cook to the device and you see the results, and then you tweak as you go. You have to build lighting and as well as cook at the same time so that you can see what are the changes that are being made to the headset itself. So let's get started with that. Let's start by adjusting the scene a little bit and seeing what we get. Let's start by adding a point light to this area, which is kind of dark, and adjusting the light. We want to first static lighting, and then let's reduce the attenuation radius so that the light is only concentrated here. Then I'm gonna reduce it to half. Let's change the color, a little orangey, and we're gonna add another light on this side. Now we have to save the scene and we have to build the lighting. So to build the lighting, we just come into build lighting only, or Control Shift semicolon. And we built the lighting. Now, as you can see, the lights are built. And if I move the light out of the way, you can still see the contribution of the light. And this is because the light, even if I move it, is already baked into the scene. So this is what we wanted. Now next, you want to see how it looks in the Quest itself. So we want to cook it to the device. Click launch, or if you haven't selected the Quest, go into the little drop-down menu and click Quest, and it'll tell you what scenes are needed to be saved. You save. And once it saves all your scenes, it's going to start cooking into the device. And you're going to see it here. And you can also see the process going out in the output log. You can go into the window, developer tools, output log. So now that we completed the build, we can see difference in the scene. And as you can see, I have already built those two lights, and you can see the lights already baked into the texture itself. But you see that the scene looks pretty different from what I actually have in the viewport. My viewport looks extremely dark compared to what I'm seeing through the headset. All around. And I can see it as well here. It's pretty dark because the lighting on the headset itself, it washes out any darkness that you may have. For you to actually see this dark scene in my headset, I have to reduce the intensity of the light, and this goes into the process of adjusting the light, building the light, and cooking to the headset. over and over and over to get this scene looking as I envision it. So this is the difference between doing your lighting on the scene and then seeing it through the quest. Also, you can see that on the quest, I have an error saying that I have to rebuild lighting. That's because when I put to the device, I moved the lighting before to demonstrate that the light was baked into the texture. And since I did that and I saved the scene, it registered that this light is not baked, or the lighting was not built after I moved the light. So when I cook to the device, it's giving me that error. So those are the type of errors you get once you move lighting, or you have multiple dynamic lights or stationary lights one next to each other. You're gonna see that type of errors on your scene. Now there's another trick that you could do to fake lighting, and this is done through the material. So in our case, for our game, we have an inventory. In this inventory, you can grab objects, and these objects are dynamic. By default, dynamic objects do not receive static lighting. So we want to have a stationary light or a dynamic light to light them. But since it's very costly in VR, we decided to add a emissive material with a default intensity value of 0.2 so that it looked lit. And for us, this technique was key to achieve the look and performance without using any dynamic lights. Now, if you take a look of our material, we have a pretty basic material, which we have a diffuse, we have a roughness, metallic, an emissive, AO, and normal map. And we also have a displacement, which is not active currently. And now we have an texture that is RMO, which stands for roughness, metallic, and occlusion. So now the way we did the inventory texture was we have a diffuse map. This diffuse map has an alpha channel, and it goes into the alpha channel, which is pretty basic. Then what I did is, since we have an emissive channel, and this emissive channel is for any texture that has an emissive property, and I have an alpha mask for this emissive, you can change the color for the emissive and the intensity, right? In our actual material, you can turn on the emissive channel, which is up here. And once you turn it on, you get a slot to put your map on, as well as an emissive color and intensity parameters. How I did this was, for our inventory, I lerped this emissive channel that I've created with the diffuse color. And I multiplied it by 1, and I created a parameter called inventory. That is going to be what blends between our emissive and our diffuse. And everything is connected to our emissive color. So then on code, when you can access this through the code, when you put an item into your inventory is going to be checked, and the parameter is going to be changed into 1. So now, as you can see here, we have a falsely lit item that is going to be in my inventory. Once it's out of the inventory, this is turned into 0. So this is how we access our inventory items. So once you open up the inventory, like so, item has an inventory parameter set to 1. And once I grab it, that parameter is set to 0. So you can see the difference in color. That if I put it back in my inventory, you see that it has the emissive channel turned on. Once I take it out, the emissive channel is turned off. And if this was an item that had an emissive property, like an emissive channel, you will see, let's say the eye was emissive, like the glowing eye on rock. You're going to see it here, which you see it in my inventory. You're going to see everything just emissive, including the eye. So that's how we faked most of the items and some of the objects that we interact with, so that we don't have to recreate the lighting in the entire scene. There's another method that we can also do, but it's more tedious, especially because if you buy asset packs from the store, then that means you have to do this process over and over and over again. And it's pretty tedious. Let's say we go into let's say this pack, and I want to modify the lighting on these particular assets. I have to export all these assets, go into substance, and bake the lighting into the texture itself. And as you can see here, I have all my textures. But then if I want to bake the lighting into this texture itself, I had to export one by one and export these textures back again with the lighting baked already into it and bring it into the game. Then all I need to do is create a material that is fully unlit. I'll basically create a tree like this, but instead of color, I have a texture, and it's gonna go into the emissive color. And then that way you don't have to put any lights in your scene, and you can just use the fake lighting created by you in substance. But that's a very tedious work. I won't recommend that unless you're doing your game from scratch and all the assets are coming from you. I will not recommend to do that process because it's going to take you a very, very long time. This is an example of an asset that has been created, and you can see here, let's say, so in this asset, you can see we have a baked lighting, which you can find it here. So baked lighting, and this is for stylized objects. And in this one, you can go into the baked lighting section, and here's your fake sun, which you can increase and decrease. And then you have two lights, and these you can change color. Make it red, and you can see the lighting having an effect. So let's say you want to fake lighting on all your assets. This is the way you do it. And then once you bake the texture on it, when you export the textures, they're going to have all this information baked into it. And that's how you do the whole process. This is why I'm saying that if you're going to do this, try to do this on your own meshes rather than packs. So now let's do a little test with another light. Let's take a point light, and we want to light this statue right here. And all I want to do is light it up. One thing that you could increase is the indirect lighting. So what it does is this light is going to bounce off the other walls, and it's going to lit the environment a little bit more once you bake. I'm just going to leave it at 1, but let's for testing purposes, let's add 3 so that you can see the difference between this scene and the one on the headset. Now that we have that, we can build the lighting. By the way, this tutorial and this level has been brought to you by our new VR title, Escape from Nefertiti's Tomb. Go check out our trailer, link in the description below. Now that we have our lighting built, now we can cook to the quest. Now that my scene has already cooked to the device, let's take a look of how it looks, the difference between the main scene and what I'm seeing on the quest. So this is what I'm seeing on the quest. And as you can see, this area right here is pretty lit compared to what I have here. So take a look. There's a major difference between what I see on the headset and what I'm seeing on the viewport of Unreal. And the reason this actually happens is because in Unreal, we use Shader Model 5, which is DirectX, OpenGL, for PS4, Xbox, for computer generated materials and shaders. For mobile, it uses Android ES 3.1. This is what mobile use. The only problem is that we have a preview here, but this preview shows you somewhat what you're going to be seeing on the headset, but not quite the same. Now that the scene itself, let me move back on the headset so that you can see a one-to-one comparison. That the one on the viewport is really washed out. The one on the headset has more saturation and it looks more vibrant than the one on the viewport. So you can use this view as a general guideline. This will definitely not show the entire picture. This is for general purposes only, just to get an idea of how it's going to look, but it's not going to give you the actual look of what you're going to be seeing on the headset. Now, one other trick that I wanted for you guys to know is with the skylight. If you bring a skylight into your scene, you're going to see that your scene gets really, really bright. This is because, how we said before, is going to take my outside image, which is my cube map, and bring it into the scene and light all my meshes and hit it with the correct reflection of the sky. On the actual skylight, you have the same 3 mobility settings. The difference between these mobility settings is that only in static, for you to get an update of any changes that you did to this light, you have to build the lighting. It will not update unless you do that. Even if you click recapture down here, it's not gonna update. You have to build lighting in order for this light to be updated in your scene itself. In stationary though, and in movable, this light updates as soon as you change it. In stationary, you will want to just hit the recapture button and it will update. In movable, it's gonna update all the time. As soon as you do a change, it's gonna update. Even if you increase the intensity, you still have to update it in static and in stationary. In movable, you don't. That's the only difference between all the lights and the skylight. And this wraps up our tips and tricks video for VR. Until the next one.